Software Engineering Radio, episode 64, Architecture and Business with Luke Hohmann. Welcome, listeners, to a new episode of Software Engineering Radio. In this episode, we are going to talk to Luke Hohmann about, or actually, how do you pronounce this in correct?
Hohmann.
Hohmann, okay.
Hohmann.
Because it is also more or less, you could pronounce it German.
Well,
so.
I'm told my ancestry is German. So.
Yeah. Okay. And we're going to talk about the non-technical aspects of software architecture, how to build products, how to integrate technical architectural stuff with business concerns. Before we do that, I briefly want to thank the organizers of the OOP 2007 conference because they've been giving us a room where we can actually record this stuff. So thanks, Wolfgang Reuter from SixData.com. Very good, so we can do a professionally sounding recording here. And so before we get into the topic, Luke, I think it's a good time to introduce yourself a little bit, what you do, what your kind of background is, and why you're here today.
Thank you. Hi, everyone. Well, my background is kind of interesting. I started working at EDS, the big systems integrator, and I spent 10 years at EDS. And my first job was pulling cable underneath raised floor. Mm-hmm. So no programming, just running around and cabling. And then over time, I did a variety of things for EDS, programming and management, and I eventually became a vice president of engineering at a subsidiary, and I moved up the ranks, if you will, in management to try and build better products for people. And then I joined a company called ObjectSpace, which was a object-oriented training and consulting firm in Dallas, Texas. Mm-hmm. Lots of fun people have come out of ObjectSpace. Graham Glass, Craig Larman worked at ObjectSpace. So lots of people worked at ObjectSpace.
Creative place.
A very creative place. I ran the training division and taught lots of C++ and Smalltalk and OOP and OA and D. And then from there, I did some more products. I moved to Silicon Valley, where many products are created. So I started moving more and more into products, and I started becoming just increasingly convinced that the business issues of a product company and software are deeply intertwined with the technical issues and the architectural issues. And in fact, this notion that you can kind of separate the architecture and separate the technical concerns became increasingly misleading to me and not accurate to my experience. So I did some products and did a variety of things, and eventually I decided to become a consultant to see if I could move the industry forward by helping developers both talk and work with the product team, and also by helping the product people understand technical concerns, trying to bridge that gap that it naturally exists, but if the gap is too big, you get problems, and if the gap is too small, you get problems. So there's a reason that there's a gap, but we want to have an ability to work with the other team, if you will.
Yeah. So then one of maybe the first important distinctions or statements is that we're specifically talking about product development and not necessarily about the typical, IT project.
That's correct. And in fact, my good friend Martin Fowler, my book is, I enjoy being in his series, but I remember when Martin and I were talking about it, and Martin said, I'd like to publish your book, and I said, well, it's a product-centric book, and it doesn't meet every kind of development, especially the vast and very important part of IT. And Martin read the book, and he said, no, I think it's really important for IT people to also understand that the work that they do in IT does need to support the business. It may not be as direct as a product, but they still have a role in supporting the business. And I think Martin's right. Yeah,
and also I think it is sometimes a good idea to view a project as delivering products.
That's right.
So that gives you a different perspective on, like release management and these kinds of things.
That's right. And Martin said the same thing. He's like, look, the same disciplines and the same activities of putting version numbers for a product are just as important for putting version numbers in IT, because you have to know what you've given. And also the whole notion of customers, right?
Yes.
IP people have customers too. So there are a very small number of things that I talk about that don't quite relate to the IT side.
Yep.
But most of the things that I talk about do. And most of the things I care about, the IT people care about too.
Okay, so then let's talk about it.
Let's talk about it. Let's go.
The basis for all that is obviously software architecture.
Right.
And we've had discussions about technical aspects of software architecture all over the place. So we're not going to repeat that in very much detail. But so you said that you can't easily distinguish the technical software architecture from like the product development, product roadmap, product features. So can you give us a little bit of an overview why this goes together and where are the join points?
Yeah, so the easiest place to find the join points is to look at the way a company makes money. And what you find is as you examine the ways companies make money, you find that the architectures of the technical team to support the way the company makes money become very different. I'll give you a concrete example.
Yeah.
Let's say that you're an enterprise software and you are going to license your software on an annual license. This is a very common choice, and it's a very good choice, and it makes sense. The architecture for managing that license is very different from a company who says, well, I'm going to license my software using concurrent users or named users. Because in one architecture, you're tracking time. In a different architecture, you're tracking logins and user IDs. And let's further distinguish it. Let's say that the company was managing transactions, and they said our software processes cell phone calls, and every time you make a cell phone call, we're going to look at the attributes of the call and then create a billing system that goes along with it. Well, that's again a completely different technical architecture to support the business choice of how do I want to make money in my market. And we have lots and lots of books that talk about, pipelines and Mary Shaw's book and Martin Fowler's book, and these are all really important things that we need. Grady Booch's cataloging architectures.
Yeah, that's cool.
Which is really good stuff. But what I think we're still missing, and what we're trying to create our own catalog and share through the book and through other mechanisms, is when your business is making money a certain way, here's a set of natural requirements that go to your architecture. Like if I'm transactions, I have to know the life cycle of the transaction. I have to have identifiers. I have to have ways to audit them and understand what the transaction processing life cycle is. Again, very, very different from someone who's looking at, say, named users or concurrent users or counting CPUs like a database does. These are all very important distinctions.
So just to clarify or to make sure people know that the book we're talking about is called Beyond Software Architecture?
Yes, this
Beyond
is
Architecture?
Beyond Software Architecture.
Okay. And so that's the context in which we start this discussion here.
Yes.
And we'll put the URL, obviously, or the link to the Amazon page into the show notes. Okay, can you give us a little bit of a product development primer? So what happens if you develop a product? What are the most important steps in doing that? Maybe also in contrast to typical IT projects.
Yeah, so in most projects there's a great degree of commonality, right? You have some idea of something you want to do, and then you have some sequence of transformational steps to produce working software. So independent of whether it's product development or IT, you can distinguish traditional software responses to that by the different methods we use, like the Berry-Baim spiral or the waterfall or Scrum or Agile. So it's really a question of how am I transforming these ideas into some kind of working software. Where product management differs, and there's many dimensions in which it differs from, say, traditional IT, is that the product management function is trying to determine value in such a way that you can charge for it. Whereas in the IT, you're still delivering software that has value, but you're not going to price it, you're not going to sell it, you're not going to distribute it.
You basically pay for the development time.
They pay for the development time. And but the transformational sequence to me is the same. It's what you do when the software is done that makes all the difference in terms of IT. You install it, you train it, you use it. In products, you install it, you have to sell it, you have to put it through channels. You might offer it directly over the internet. You might have a direct sales force. All of those complexities make products a little different from just IT.
One of the especially important things when developing a product is that you can't update it easily. You have to have a roadmap. You have to have well-defined versions. You can't maybe today with the internet it's different, so you can easily, put a patch into what you already have. But there needs to be a more explicit plan of the different releases and versions you have. So I think this is also maybe a difference.
Yeah, so you touched on actually 2 points. One is the notion of a roadmap, and the other is the notion of how do I support and service my customers in the field. Let's take the roadmap first.
Yeah.
So one of the things that we think is a dangerous thing is when product marketing people and engineering people simply just say, I'm going to have this release on this date with these features. That's what we call a release train. And that doesn't provide very much information to the company or the engineers in the sense of, well, why is this release important? Why do people care to acquire this release? Why does my customer want to install it? Yeah. And more importantly, software has natural opportunities to be installed. And what I mean by that is that every market is governed by a set of events and rhythms.
Yep.
And you can't just install software anytime you want. You just can't change things around whenever you want. So, for example, if I'm coming to a conference and I have an important presentation, I may not want to upgrade my operating system while I'm on the plane on the way to the conference because if something goes wrong, I can't recover from it. Yeah. And similarly in business, we can't just arbitrarily update things or change things. And so one of the things that a good roadmap does is it moves beyond just this release in this time frame, and it provides the understanding that the product team has about why will the market care about this and why will the market absorb this. The other part about this is that, and I talked about it yesterday here at the OOP conference in my tutorial, is that we expect that the product team has an understanding of how the market's going to evolve and how the features of the product are going to improve. Well, we also understand that technology isn't static, right? Yeah. Technology is very dynamic.
Yeah.
It's very
too dynamic, maybe.
Well, too dynamic in some things. Yeah, I can see that. But the point is that one of the people who were in my tutorial said, "Hey, how do I communicate to my product team that I've got to change my architecture because something changed underneath me? You know, I'm fine with the old database, but the database vendor changed versions and they no longer support it. So I have to change, right? And that happens all the time in our industry. Things change. Yeah. Sometimes it feels very unstable. And so what I talk about is a well-constructed roadmap is going to give the technical architect an opportunity to communicate their understanding of how things are going to evolve and their understanding how things are going to change. And by putting those into the same diagram and the same picture, you create an opportunity for the technical team and the business team to actually work together over time to meet the needs of the market. And we find that this technique, which we call market-driven roadmaps, where the technical leader is in the room at the same time with the product person creating that vision of the future, has this tremendous effect of helping link the two teams together and helping them be productive together. Now, the other part that you talked about was this notion of how do I deal with updates in the field? How do I deal with service in the field? And notice that that's a business decision that's affected by the architectural choices.
Exactly. Yeah.
Right? So the business team says, you know, Marcus, it's really important that we be able to update the software when it has a bug. Yeah. And so as an architect, you kind of scratch your head and you say, well, okay, what do I need to do technically to implement the business desire or goal of having it be updated in the field? Well, then you would say, well, I have to componentize my system. Well, that's just good engineering. Yeah. But more importantly, I have to identify each component in such a way that not the system is versioned, but each component is versioned. Yeah. So I can say that, you know, the bug is in this module version 2.2, and I'm going to go download this new particular module version 2.3, and then it creates a configuration sophistication, and then you have to do your testing infrastructure where you're testing the permutations. So again, to me, that question is really gets to the heart of what I care about, which is the business has a goal called make it easy to update, and the technical team can do that. I mean, we know how to do this. We know the techniques to do this, but it's intertwined with the business, where we have to go back to the business people and say, well, what if I'm building embedded software? And you have to go to the business people and say, okay, if you want me to update the software in the field, then I need more money for the hardware because I need room in the hardware to take the new update. And then you have to go figure out the new economic model because now it's not, $5 in material cost, but $7 in material cost. And you have to figure out if you can make money or if it's cheaper, maybe not for the environment, but it might be cheaper for your business to not make it upgradable and throw it out.
So is this where the two terms marketecture and tarchitecture come into play? Yes. I mean, but most people know the term marketecture, I guess, and that has, in most circles, has a bad connotation because it means basically drawing PowerPoints in a way that people like the pictures, but that's not what you're talking about, I guess.
Not at all. So in the book, I introduce two terms. One is marketecture and the marketect, and the other is tarchitecture with a T and the tarchitect. So most of the time I think of the technical architect as the tarchitect. And if you think about what they're responsible for, you can kind of see the distinction of the marketect and the tarchitect. So a tarchitect is responsible for the overall architectural style. Is it a layered system? Is it a pipeline? Is it a blackboard? Is it a kernel architecture? Yeah. The marketect has the similar kind of responsibility for how you go to market, meaning how do you charge customers? How do you bill them? How do you service them? How do you support them? These are all choices that the marketing team makes about how they want to work with the market.
So is the marketect the same as what some people call the product manager?
Yes, in many cases and in most cases, the product manager is the marketect.
Right, okay. Mm-hmm.
And I'll point out that in our industry, we've learned that technical architects are special people. And they're rare, and good ones are rare.
Yeah.
And we've also learned that in product management, actually good product manager is a very rare person. Yeah. There's many product managers who are ex-engineers who aren't particularly skilled at it because they want to design the system.
Yeah.
And then the other problem with product managers is they come with no technical background of any kind, right? So I got an MBA in finance, and now I'm a product manager.
Yeah, it doesn't work.
It doesn't work. There is a need in our particular industry to have some unique skill, and in fact, that's one of the things that my company is devoted to trying to help understand, which is product management of software technologies is different than product management of coffee and Coca-Cola and chairs. They're different skills.
Why is that?
Well, the fundamental reason is software is not sold. It is licensed. It is intellectual property. So when you bought your chair, you didn't have a license agreement, or when you bought a pen.
Yeah, maybe it's going to be there at one day.
Well, okay. But that's when the chair gets smart and it knows how to make itself hard or soft based on whether you're tired or not, right? Because it has sensors built in. And some software person, right? Because software is really cool. Some software person wrote the software to make the chair adjustable. Yeah. But right now, like I'm holding a pen in our interview, and this pen was bought. Yeah. I own it. Right? I physically own this. I could sell it to you without restrictions.
True.
You cannot do that with software. And so one of the most fundamental distinctions between software as a product versus any other kind of product is the notion of intellectual property and licensing. Mm-hmm. And how the license terms both affect the software, affect the technical team, and affect how the market evolves.
But also, I guess there is more like technical reasons why software is different from chairs, because people always say that chairs and many other things are governed by all kinds of physical, chemical, and biological laws.
Absolutely.
Which you can't negotiate away.
That's
in
right.
software, at least people think it's different.
Well, and in many ways it is. And one of the things that changes about software is that because the hardware continues to improve so rapidly, we can actually do things now in software that we couldn't conceive of, mostly because of algorithmic complexity.
And of course, I
you forgot to turn off your phone.
So just to make sure, this is me, not Luke. So he probably turned his phone off.
No, but you're right. I mean, the whole and I can't disagree. Right, the whole notion of physicality of and for example, the software. It's interesting. Software bits don't degrade, right? They last forever, where chairs and physical objects degrade.
Yeah.
But the relevancy of the bits degrades because of changing in the environment and information half-life.
That's a good point, actually. So the value of the software degrades too. It's not that it mechanically fades away, but its usefulness.
Yeah. I mean, how many of us find usefulness out of DOS 3.1 anymore, or CP/M, or an old operating system?
Actually, I just recently found an emulator for the Amstrad computers back then with all the games. So I found that useful.
Right.
Yeah, of course, but that's a good view. I didn't think about that yet. So software actually ages in the same sense as hardware products age. It's just that it's not physically deteriorating.
That's right. And so it confuses people. Like, so software people, when we say that, we actually we're comfortable with it. We go, yeah, it makes sense. Whereas non-technical people go, I don't understand. It's not wearing out. Help me understand.
Yeah. So one thing that I'd like to talk about a little bit, which is a bit beyond, I think, beyond what you describe in the book, is product lines. How is product line development different in that sense? How is a product that's part of a product line? Is there different things we with regards to the process and roadmap?
First off, I am very excited about the work on software product lines. I think it's some of the best work that's ever come out of the Software Engineering Institute. I'm very excited about it.
Yeah.
I really, and I know that in other places around the world, product lines are becoming more prominent. I do think that there are some differences about product lines because product lines are fundamentally about an architecture that was created with a business purpose in mind. And that's different than architectures that were created with a indirect business purpose in mind. So for example, we might talk about scalable transaction processing architectures. And yes, the business purpose was scalability, whereas in a product line architecture, you're typically analyzing the product line relative to a set of market segments to create that investment right up front. So I think all of the normal practices that a product manager does and many of the practices that an architect does are appropriate. I think they get extended and emphasized in a product line architecture.
It's somehow funny. I've been discussing this product line stuff with several people recently because it's also, for me, it's very interesting. And maybe even we recorded this in one of the previous podcasts on product lines. I don't know. Anyway, so Michael Kirche once said that when he looks at this product line stuff, most of this stuff is just software engineering done right. So it's not necessarily specific to product lines. It's just that those practices and best practices become even more important if you do product lines.
Yeah, and I've had that point of view too because I've read the seminal book Software Product Lines and I read it and I'm like, well, I've done that. I mean, that's how I've done systems in the past. Yeah. I think the difference is in the expected output of a software product line is that you get multiple instantiations relative to market segments and domains, whereas software engineering done right is still typically done for one particular instantiation or one particular domain. And I think that's a worthy distinction.
Yeah, of course. I mean, there is this focus on extendability and of the ability of explicitly manage variations and blah, blah, blah. But many of the things that people talk about in product lines would also be useful in non-product line embedded products.
Yeah, and notice that what we're really distinguishing is the input versus the output, right? The input to the well-designed architecture is the same as the input to the well-designed product line. I want to achieve this goal. Yeah. It's the output that's different. The output of a well-designed single architecture is just a single architecture or a single instantiation of the system. Yeah. The output of a software product line is multiple instantiations of that system in controlled ways with different price performance or different structural characteristics. But the other thing that I've been finding as I've worked with companies who are doing software product lines is that people who have built multi-platform software and people who have built software that goes that is highly internationalized tend to have an advantage in thinking about product lines because they're used to the notion of I want to have this core that is expressed in different platforms or I want to have this core that's expressed in different user segments or populations. Yeah. And so those people naturally are employing the good practices of software engineering and they seem to be adopting product lines faster.
Yeah. So let's talk about some of the aspects that are important to consider when discussing about the influences of business aspects on software technology.
So let's take one of my favorites, technology and licensing. It's virtually impossible to build a product today on your own. Mm-hmm. You're building on an operating system. Yeah. I mean, the embedded guys sometimes can do it on their own, but even embedded teams will often use embedded operating systems. Yeah. Well, again, going back to this notion of software isn't sold, it's licensed. Everything that you're building on has a license that governs its terms of use. Mm-hmm. And so as an architect, you're not only making technical choices about the performance of the component or its functionality, you have to start being aware of the license agreement. And you have to say, I want to bring in this component, and by using this component, I get this advantage, but I have to understand the terms and conditions of the use of that component. And I'll give you a concrete example. Some years ago, we were brought in to work with a client who wanted to build software as a service, an ASP. And they wanted to build it on a particular vendor's J2EE container. Well, as it turns out, the vendor license for the J2EE container was different when it was hosted versus when it was deployed on site. And the economics of the license for hosting was untenable. It was too expensive to host it using their container license. So we had to pick a different container. And in the process, yes, theoretically, J2E containers are completely portable. Practically, they're not, right? Yeah. So then we had to spend about 2 months of development cost rewriting the whole thing to get into get to an open source J2E container. That's the kind of issue that technology licensing can come into play. And of course, with open source, people who don't understand open source licensing or the issues of open source licensing can make mistakes. Even they may not be trying to do the wrong thing, but they may make a mistake because they don't understand the license terms.
Yeah, and that's something. I mean, I'm using quite a lot of open source software. I'm also producing open source software in the open architecture team. And when we became part of the Eclipse platform, so we moved from just another open source project on SourceForge to becoming part of the Eclipse platform or the Eclipse project. And we had to do quite some, I think the term is due diligence, finding out what kind of libraries we were using and making sure that we don't use anything that is, from a licensing perspective, unclear. And we didn't care about that before. I mean, it's open source. Just use it.
Yeah, just use it. Well, guess what? And now you care.
Yeah, absolutely. We had to.
Yeah, you had to.
Tough.
And so that's an important consideration, I think, of any architect. They have to know these things. And what's interesting is that you might say, "Oh, no, Luke. The business team should know that." Well, the reality is the business team can't understand the meaning of the term. Yeah. So they can walk up to you and they can say, "Hey, this license says that I'm not supposed to expose the API." Well, what do they know about exposing APIs? Yeah. And you as a technical person say, well, what I'm going to do is I'm going to wrap the API. Yeah. Well, a lawyer who's smart in both would say, well, wrapping an API is similar to exposing it because you're not doing any value-added work on top of it. Yeah. And da-da-da-da-da. So the technical people really do have a responsibility to understand a little bit about this. Next one that we like to talk about is portability. Portability is a really funny thing, right? Because a lot of developers care about their skill in writing portable code.
Yeah, I was about to mention that.
Yeah, it's like I know how to write portable code, and it's a rare skill, and that's true.
And let's add another indirection layer so we can exchange a database and
we
whatever.
can do the more database, And so what I find is that portability is not a good choice when developers think it's cool, or when early customers in the early phases of a product growth say, well, I've got different needs and I want you to support them. What you really want to do is in a product team, you want to evaluate the notion of portability based on market share. It's economics. Yeah. How much does it take me to write the portable code? And does it make sense for me to support that other platform? Now, what's interesting is that I explicitly said write that code, and hopefully your listeners are saying, no, it's more money than just writing the code. And it is. You've got to have testing, QA teams. You've got to have support teams. Your sales team might have to have, let's say you're selling enterprise software and you're selling it on different platforms, like a Mac platform and a Windows platform and a Solaris platform. Well, does your sales team have to be trained in all platforms? And what about the differences in platforms, et cetera, et cetera? So I understand portable systems development. I have managed teams doing portable development. I've created portable products. More often than not, though, I think that portability is overrated.
Yes, I would agree, because especially, for example, on the database side, I mean, if you're developing real products that people can deploy on their database, then it's different. But typically also in IT projects, I mean, your customer will most likely never ever change the database because it's too expensive. They have these typical, lifelong licenses with Oracle.
Well, it's not only that it's too expensive. So let's say that you're a company that has a big investment in Oracle, and it's not the data that's the expense in any system, right? It's the humans, right? So it's not just the fact that you've got this big licensing agreement with Oracle. It's that all your DBAs know Oracle, and they know the ins and outs of Oracle, and they're comfortable with Oracle. Not that Oracle's perfect or it's terrible. It's just that they understand how to make Oracle work. So then you walk up to them and say, well, I want you to use this new thing because it's cheaper. And they're thinking, but I've got to retrain everything I've learned in my career. And what I've often seen is that when people make those kinds of changes, the people change. They go find a job where they can use Oracle.
Yes, absolutely.
Because I know Oracle.
Yeah, that's especially true for databases. There is a lot of know-how in databases.
There's a lot of skill, right? There's a lot of skill.
So I think we talked already about a little bit about the deployment stuff, updatability and things. So do you want to add on that?
Well, when I talk about deployment, one of the things that I write about is the notion of people put a big distinction in the world right now between if is it hosted at the customer site or is it hosted in a data center. And some people call those application service providers. In Silicon Valley, the cool term is software as a service. You know, you run it like Salesforce.com. When you're talking about the architecture of a product, I think in general, the architecture of deployment should be independent of the architecture of the business functionality. Meaning, I shouldn't bake in assumptions about how I've deployed, and yet people did that all the time. I mean, what they found, for example, in the early days of hosting software was that the software was inadvertently designed to be one customer on one database. And then we had to learn how to redesign database tables to have what's called multi-tenancy. So that's one issue, right? And so when you really approach it from a fresh perspective, what you want to say is, I have to expect in the modern world that my software is going to be flexibly deployed. Some customers are going to want to put it on site. Some customers might want me to host it, or I might want a third party to host it. And therefore, I'm going to make choices in my architecture so that it can be flexibly deployed. And again, to your comment earlier about, well, product line architectures are just really fundamentally good architecture design. I think deployment choices are fundamentally good design choices. Now, I want to add one thing that I didn't write about in the book that is an important distinction. There are capabilities that you can create for your customers when your software is hosted that are different than when it's deployed on site. I'll give you a concrete example. Let's say I'm doing a data acquisition system for supermarket HVAC controls. So I've got supermarkets and I'm managing the temperatures and the thermometers and the lighting systems.
HVAC stands for heat, ventilation,
air conditioning. So I've got this system that does that. Now, if I put the software at my customer's site, they can look at things like trends and they can understand how the weather impacts their energy usage. But what they can't determine is how their store is doing relative to other stores from other companies. When I host it, I can aggregate the data, and then I can do what's called syndication or syndicated data analysis, and I can get performance statistics about how I'm doing relative to other people. So what I try to get the business team to first think about before I talk to the architectures is I say, are there unique services or information that you can provide to your market when you host? And if the answer is yes, I can get something unique, well, then it's a little bit more compelling to go hosting because you're providing a better business value. And you're not making the choice based on architecture, because most good architects, once they understand that hosting is a requirement or flexible deployment is a requirement, they say, oh, well, I'm going to design my system to be multi-tenant. And then here's what I need to do to be multi-tenant. And then you add the security of the database and things like that. But the real point is, you got to bring it first to the business value. What am I offering to the market that's different when I host it versus when I don't host it?
Wisdom of the crowd, right? That's right. That stuff.
And of course, sometimes the crowd is idiots, so you don't want to do that.
So before we talk a little bit about innovation and product innovation, I'd like to touch briefly on one thing that I personally find quite important, and that is branding. I mean, I haven't ever really done product except maybe the podcast. I mean, in some sense, the podcast Software Engineering Radio is a kind of product.
It is a product.
It is a product. I'm wearing this T-shirt that does some advertising. I have, that's
a brand.
You have a logo, you have a name, you have a website, you have a way of doing the episode. So you're really building a brand in some sense. And so I think you'll certainly have some thoughts about that.
I do. So in the book, I talk about brand and brand elements for software architectures. Again, this is one of those areas that does distinguish a product from an IT project. IT project doesn't have a lot of need for branding. Yep. But it's really funny because when you drill into the details, you find that brand issues surface in many funny ways. Like, for example, if I'm installing software on my laptop, I usually put it by convention in Windows in C program files. But now I have a question. Do I put the name of the company as the directory with the name of the product? Do I put the name of the product? Do I put the version of the product I'm installing into the directory structure? Similarly, when I'm doing software, let's say I'm running software as a service and I put my company's logo out there. What if my company is using it internally with their users? Maybe they want to see their logo. And now I have to define what are the standards of the graphic and how do I upload it and how do I change it and who can upload it and who can change it. So branding and brand elements are very important things that we need to understand in products. And the architect needs to have an awareness of it so that they're using them properly and making the right choices for changeability and extensibility, which is kind of funny.
It's also important whether you try to put your company name in the foreground or your product name.
That's
right. For example, in some cases, the company name is the same name as the product name, Google, Skype. I mean, Google has other stuff than its search engine, but the search engine is Google.
That's right.
So I think it's also important to make this distinction, whether you want to make your company a well-known entity or whether you're really like building a product which
has a brand.
Which happens to be developed by a company.
And this is all the marketing side of things. For example, it gets funny when companies acquire companies. So, for example, Symantec acquired Norton Antivirus. Well, the Norton brand was so strong that they've never thrown it away, and we still refer to it as Norton Antivirus, even though technically it's Symantec's Norton Antivirus. We call, and it's sometimes we say we tend to say Microsoft Word, but we tend to say Excel. We don't say Microsoft Excel.
True, yeah.
So
now that I think about it.
When you think about how people talk and the language they choose, it's very interesting to see when is it the company, like you said, is it company product or is it product?
Cool, yeah. Okay, so let's look a little bit about this whole business of innovation and to some extent also requirements gathering, I guess, because as we said, we talked about that a little bit in the preparation of this episode, and I think coming up with a product idea is typically something very creative. There isn't much of a process involved. And then, as you explained, you release like version 1 and you have a couple of things on your backlog that you wanted to be in 1.0, but it didn't get in there because of time to market considerations. So version 2 is also typically simple. You just add all the stuff you always wanted to add. But now, what do you do next? How do you communicate with your users, or how do you do this?
That's right. So having been in several startups, they typically have the same structure as you outlined, right? Some really creative person says, "Oh, if I see this problem and this need, and I'm going to write some software to go fix that problem." Yeah. And they may be solving their own problem, or they may have done some market research or some testing or whatever to figure out that it was worth doing. But when you get into release 2, when you get into release 3, you start to say, well, what do I do next? How do I keep my innovation pipeline flowing? Yeah. And so what I found was that being a good engineer, I just would walk up to my customers and say, hey, what do you want? Yeah. And of course, that doesn't work. So then I went to the field of usability.
It doesn't work. Why?
Well, people don't know what they want. I mean, the standard, when you ask someone what they want, they don't really know. They kind of can tell you what they don't like, but they kind of can't tell you what they like. It's kind of like, when you're dating, right? It's easy to see someone that you don't like, but it's not always hard to predict what you do.
Yeah, okay. Yeah, good point. Yeah.
We're discriminators as humans, right? The brain is designed to discriminate. Yeah. So then I moved into the field of usability, and I read all about usability, and I learned about prototyping, and I thought, wow, prototyping, that makes it better, right? Because, through paper and pencil sketching in interfaces, you can show them interfaces, and you can get rapid feedback, and there's lots of good work in that field. And it's very important to do prototyping, but I found that prototyping didn't actually help me understand the motivating need of the customer. It helped me understand whether a customer found my idea acceptable, but it didn't necessarily solve the problem.
Yep.
So I started playing around over about 10 years with different games and different techniques. And what I found was that when you let people do activities, you can get much richer understanding of what they're trying to accomplish and the problems they're facing. So after about 10 years of doing this, I wrote a book called Innovation Games, which was just published. And in Innovation Games, I describe 12 ways to work with your customers through activities or games that give you insight into deep needs and deep understanding of what they want. And the goal of the book is to provide readily accessible tools to software people or technical people, because we're frankly not trained to talk with customers, right? Marketing people, they're giving classes on this. Engineers are giving classes in, algorithmic complexity. Not a very good way to learn how to talk with a customer. Right? So the goal of the book is to outline in very clear, very simple steps. Here's how you plan the event. Here's how you bring customers in. Here's what you do. Here's how you post-process the results. And here's how you use them in your product planning purposes. And we found that these games are very, very successful. They've been used by lots and lots of different companies. They've helped improve products. They've helped product strategy. They've even created new product lines and product offerings at companies based on the ideas and the innovations that occur out of the game.
Can you give us like 2 or 3 examples of such games so we get a feel?
Absolutely. So one game is called Buy a Feature, and it's used to help understand customers' priorities of features. So let's take a premise that a development team is a finite resource.
Yes, usually. So that means you don't have the ability to do everything you want. So what product managers typically do is they go out and talk with customer 1 and get what their needs are, and then they talk with customer 2 and they get their needs, and they keep this pairwise conversation. They get a bunch of customer needs and then they sort through it. What Buy a Feature does is it says, let's bring all the customers into the room. Let's price the features and give them play money. And the amount of money that we give them isn't enough to buy all the features because development is a limited resource. And let's watch who negotiates with whom to buy what. So let's say there's 6 customers at the table, and I each gave them $10, and one of the features is $40, and one feature is $30, and one feature is $20. Eventually, they're going to start running out of money. And to get a feature, they have to collaborate. And what you're watching as the developer in the room is you're watching, well, who collaborates with whom? And you find that people will collaborate to buy what they want. And the more that they collaborate, the more important that feature is to the market. But that, of course, only works if you can identify your customers, or at least a subset. If you have the typical like shrink-wrapped stuff, you can't obviously get all your customers.
Well, you can get a statistical sampling.
Yeah,
you can do a statistical sampling. Absolutely. So that's Buy a Feature. That's one game. Another game is what would be Give Them a Hot Tub. So Give Them a Hot Tub is the use of outrageous features to determine what is called the product boundary. So let's go back to product management and technical architecture. Product management is making choices about what's in and out of the product. Similarly, the technical architect makes choices about the product boundary. They say, this is in my product, or this is something I'm going to license in. Right? These are boundary questions. So what Give Them a Hot Tub does is it uses outrageous features to determine what features customers want. And so what happens is when you're presented with an outrageous idea, your brain needs to protect itself. So your brain will say, well, that's just stupid. Well, okay, fine. Or the brain will say, I didn't even hear it. Like, I ignored the stimulus in the environment because it's too weird. But the magic occurs when we give you an outrageous feature, and then your brain says, I've got to make sense of it because I've got to resolve cognitive dissonance. So an outrageous idea induces cognitive dissonance, and so your brain transforms it into something that makes sense. And it's that transformation process that gives you insight into the kind of the features that your customers really want.
So what you're saying
product.
is you're proposing nonsense, and the customer says, yeah, that's nonsense, but what I really need is like this and that.
Exactly correct. And it sounds like it doesn't work, but it actually works very well. Mm-hmm. And there's a lot of psychological research that talks about how we respond to stimulus that is nonsense. Mm-hmm. And sometimes we ignore it. We just say, oh, it's nonsense, and you move on. But sometimes we do exactly what you did. You say, well, it's really kind of nonsense, but this would make sense to me. And it's the would make sense to me
that's interesting.
That creates interesting and power and excitement.
Mm-hmm, mm-hmm.
Another game is actually based on the field of ethnographic observation. And ethnographic observation is going out in the field and working with customers. Mm-hmm. And we call it The Apprentice, not unlike the TV show. But many software people have a term called dog fooding. And
eat your own dog food?
Eat your own dog food. So eat your own dog food is using your own software.
Yeah.
The problem is that most software teams can't really use their own software because they're not the people using the work.
That's why I always say that you can't necessarily adopt the practices of the people who develop Eclipse. They're always considered as, this is a great team. They built this wonderful, stable, scalable platform, and they do dogfooding all the time. But you can, of course, only do this if you develop development tools.
That's right. So it's a great idea, but it falls apart. Yeah. So what we do with the same concept is we actually put developers at our customer site, and we have them use the software with the customer as a guide. So you can't dog food. Like, for example, if you're a software developer working on retail cash registers, like you're working on software that makes the cash register run, chances are you're a software developer. You're not a cashier at a store. Yeah. But what we will do with customers is we'll actually put the developer at a store that has their cash register, and we'll have them be a cash register operator for, say, an hour or two. And then the cash register expert will say, well, see, this is how it works. And by having that feeling of how it's really working or not working gives the developer first empathy, right? It creates empathy for the customer, empathy for the experience, and it helps them understand, wow, when I'm building software, this is the kind of person that cares about it, and this is what they have to do their job. And
it also really helps to understand the domain. I've once been working for a company who builds these huge container terminals in a Hamburg port. And of course, since I'm an engineer, I of course liked, to see these big things. So the plan was to actually go there, go on top of such a crane, and really look at what's happening and how these container transport things, drive around and how this all works, to get a better understanding of what the domain is for which we're trying to build this, this like state machine that controls the crane or whatever.
Right, because the state machine that controls a crane is very abstract.
Yeah, exactly.
And there's no emotion and there's no feeling,
exactly,
right? And engineers do much better when they have that personal connection into what customers are doing.
Yeah, especially if it's in some sense cool.
Yeah. Oh yeah. Well, everything has a sense of coolness to it.
Yeah. Banking for me, it doesn't.
Banking doesn't for you, but for bankers it does.
For bankers, Okay, so but although you talk about this stuff in the context of innovation and product development, it could also be considered as a way of doing requirements engineering.
Oh, absolutely.
Not necessarily engineering, but
no. Let's take a step back. Okay. So the innovation games are technically a form of market research, and it's called qualitative market research. And what I believe is that requirements gathering is just another form of market research. And because I define market research as any activity that you undertake to better understand your customer. So if you're undertaking an activity that is working with people or trying to understand them better, to me, that's a form of market research. Well, that's what requirements gathering is. How do I understand your needs to create better software? Well, I do requirements gathering. And the whole field of requirements gathering, there's many wonderful techniques that work. Unfortunately, some of them are pretty dry and not very fun. The real point the other point about innovation games is that there's an element of fun to all of the games. Many of the games result in people generating pictures and artwork that you can take back to the rest of the team and share with them and say, look, this is what a customer said.
Yeah.
And this is what they meant when they said it. And instead of seeing, some very boring, 12-point Times Roman font in a Word document, they can actually see customer handwriting and they can see a customer generating exactly what they were looking for.
Yeah. And I really think it's critical that you involve groups of people so you have this element of discussion, because if you just go to a customer and say, hey, tell me what you want, sketch it, then they either won't be able to do it or they will sketch the bathtub, right?
That's
completely stupid stuff that are either unrealistic or of which they think they need, but they don't need it.
That's
so you have to have this interactivity where people talk to each other and kind of negotiate the features.
And what's fun about this is that it actually doesn't have to be a big deal, meaning many companies have natural opportunities to talk with customers. They have user groups. They have annual conferences. Yeah. And what's funny about this is that, and I'm going to talk about this in my keynote later today at the OOP, but the only thing that's holding back developers from attending those events is they don't often ask. Meaning, if there's a user group meeting and you're a developer, say, hey, could I go to the user group meeting and just hang out with customers and talk with them? And then there's some guidelines as a developer, right? You shouldn't make promises because it's not your job, and you shouldn't, say things are bad or good. Don't commiserate. Don't say, oh, I'm going to fix that bug for you, because you may not fix that bug. So once you learn a couple of light guidelines of how to talk, you can participate in those events and get access to it. But you kind of got to ask that question. Yeah, because they're not going to come ask you, and they're not going to go. The marketing team isn't going to go over into engineering and say, "Hey, engineers, come on out to the user event." Yeah. But they would love to have you there.
And users would probably be happy if they were able to talk to like real experts and not just marketing people.
That's right. So it's entirely acceptable when a customer walks up to you and says, "Could you tell me a little bit more about why it works this way?" Yeah. And then you can say, "Well, here's what we were thinking, and here's how." And the customer goes, Oh, okay, that makes sense to me. I mean, it's very non-threatening.
Yeah. I think that's more or less all I had in mind. Do you want to add any, as I say, and as I copied from other podcasts, any pearls of wisdom that you want to leave our listeners with?
Any pearls of wisdom? I would simply summarize the way we started, which is business and technology are intertwined. Mm-hmm. They're not distinct. And the choices that technical people make influence the business, and the choices that the business makes influence the technical people. And understanding that interaction creates better products and better architectures.
Okay, so thanks, Luke, for being on the show, and I'll let you know once we posted it.
Thank you very much.
Thanks for listening to Software Engineering Radio. If you want to get more information about Software Engineering Radio, or if you want to give us feedback, please go to our website at se-radio.net. You can also contact the team at team@se-radio.net, although we prefer entries in our comments system on the website so other people can see what you think. Software Engineering Radio wants to thank Henning Pauli for the intro and outro music, as well as Libsyn for providing the bandwidth. This episode of SE Radio, as well as all other episodes, is licensed under Creative Commons license. See the Software Engineering Radio website for details.